All right, in this video, we're continuing our module for review, but we're looking at arithmetic sequence and series. The formulas that we're going to use, these formulas right here, let's take a look at these first two. This is to find any nth term or any term within the arithmetic sequence. Remember, arithmetic sequence is going from one number, say like 3, adding or subtracting some value. Let's say I add 7, then the next one in the sequence would be 10, okay? Arithmetic means that we're adding some value when we're going to the next number or the next term. So this is the formula that we use when we're finding any term, okay? I have a generic version that I think is superior, and you should adopt over the basic one, okay? Really what we're doing is we're changing that 1 to an I, allowing us to start anywhere we want. So I like reading this generic version as UN is where I want to end. What is the value in that position where I want to end in? UI is the starting value at I. So the jumps I need to do, I want to end at N position and I want to start, or I'm starting at the I position. This is how many jumps I need to do to my pattern. D is my pattern, okay? So UN is where the value that I want to know where I end. UI is where I start. What value do I start with? This is the jumps that I'm going to do in my positions, where N is where I want to end up, and I is where I start. And then D is the pattern. So this will find any term in the sequence. And what I'm going to do is we're going to use those formulas for the part A and part B. So we're going to take a look at that right now. So in this review example, we are given the following arithmetic sequence, UN, with the 23rd term, or U sub 23 equals 72. And we know that the pattern, the common difference, is 9. Okay. What we need to do is find the first term. So in this sequence of numbers, what is the first number? Well, we're going to use the generic formula that we have right here. Okay. So I'm going to bring it down and I'm going to write it right there. A few things I'm going to label. Think about UI is the term they give you, okay? So in this case right here, they give me the 23rd term, so UI is going to be the 23rd term, making I 23, and making the value I start on is 72. The pattern, again, the common difference, D equals 9. So in this formula, this is what I have. UI is going to be U sub 23, and then I is going to be 23. Now, what is N becoming? It is becoming 1. So if you look right here, N, U sub N is the position I want to end up, right? The value that I want to find. In this case, the first term. So UN becomes U1, which means N becomes 1. So I took this generic version and plugged in the values or positions that I want to be at. I want to end at U1. I start at U sub 23. The jumps I need to do is from 23 to 1, or 1 minus 23. And D is the jumps. So I'm going to fill in a little bit more. The 23rd term is 72. And my pattern is I'm going to add 9 each time. So I have this right here. I'm going to plug this into my calculator. 72 where I start, plus the jumps I need to do. I'm going to end at 1, start at 23. And I'm going to times this by 9. Oh, syntax here. That's okay. Go to it. I put way too many zeros, way too many multiplications. That's fine. But I get that the first term is negative 126. Perfect. So I know my first term. Now, I can use this generic version and that process to find any term, not just the first term. So let's say I want to find the 40th term. So I start that process again. I use the generic version. My end goal is to find the value at the 40 position. So boom, there we go. I know that the 23rd position, I could also use U1 as well, but I'm just going to stay consistent on this. So I know the 23rd position, that's 72. My destination is the 40th term, and I need to start at the 23rd term. So these are the jumps I need to make. I'm going forward, so again, those are my jumps. My pattern hasn't changed. It's still 9. So in the formula, I'm going to start at 72. I'm trying to get to the 40th position, starting at the 23rd, and every time I make a jump, I'm going to add 9. So 72 plus parentheses 40 minus 23 times 9. What is it going to be? The 40th term or use of 40 is 225. Perfect. Okay, again, though that was an example on how to use these formulas, specifically the generic version, to our advantage to define any term or the nth term of a sequence. What if we wanted to sum some n terms of that arithmetic sequence? So the sum of the n terms. Well, we can use really 3 things. We have this formula, that formula, and this process right here. So these are related, and this is something separate. Okay, so these are the formulas. They're just variations on each other. So you can actually go from this one to this one or back and forth. They're the same idea, just a different form. This is a different idea, but it will still get you the same idea. It's actually using that summation notation to get us what we want, okay? I'm going to show you both ways, but these formulas are helpful when we're looking for the sum of n terms. So let's go down here. So now, part C, we need to find the sum of the first 34 terms of our sequence. Well, here, let's go and refresh our memory from summation notation right here. So you can see what that looks like in the context of an arithmetic sequence. This is the process that you might want to do. What we're doing right here is putting un. We're putting that generic expression right here. How do we do that? Well, we are going to have our index start at 1 because we're going to start with the first term and we're going to add up to the nth term. Well, how far are we going? We're trying to find the sum of the first 34. So we're going to start with k equals 1 and we're going to end at 34. We're going to use the generic formula un, but we're going to replace n with the idea of k. So this is going to give us every term from 1 to 34, and the sigma, or the summation notation, is going to add them up. So it's going to be kind of like just telling our calculator, hey, find the first term all the way up to the 34th term, and just add them up. And it's going to do that. So grab your calculator, and let's do it. Click math, go up. You can even press 0, or you can go to 0. Press enter. We want our index to start at 1. I'm going to use I'm going to use x instead of k. And we're going to go to the 34th term. What is the formula? Well, I start at 72 plus. I'm going to do x minus what is, 72 is in the position of 23, right? It's the 23rd term. So I'm going to minus 23. That's where I start. This is my starting position. This is my starting value. All right. So my starting value is 72. X is my index, is going to start again at 1, go all the way up to 34. I'm going to times that by 9. There we go. I have that the sum of the 34 terms, or the first 34 terms, is 765. That's one way. That's using sigma notation. What if we wanted to use the formula? So I just grab one of the formulas, the top one, and I'm going to use it. So you can see this one is a little bit more simple in that design, but either methods work. So what SN really what just define any term. So you put n here, what we're looking for. In this case, we're looking for the 34th, or the sum of the first 34 terms. So n is going to be 34. We're going to have the first term. So we do need to use this formula. We do need to know the first term. That's fine. We found it in part A. So we're good. So the first term is negative 126. Again, we got to use n because we're going to find, or we're going to add up to the 34th term starting at 1. And we need to know the pattern. So this formula, when we fill in n, u sub 1, and our d value, we're good to go. So finding the sum of the first 34 terms, what you do is you make a fraction. I'm going to do 34 over 2. Parentheses. Now I'm going to put that 2. That 2 is always going to be there. There we go. The first term, again, is negative 126. close that, plus 34 minus 1. And 34 is that end value. And then I need it times it by my pattern. Close that parenthesis, and now I press enter. And again, the same value I get. The sum of the first 34 terms is 765. So that's two ways that you can find the sum of an arithmetic sequence. You can use sigma notation or summation notation, or the explicit formula for the sum of the first n terms. All right, guys, if you have any questions, please reach out to me or Mr. Tolson. Otherwise, I'll see you in the next video. Bye, guys.